So, hello all of you. I hope all are doing well. So, today we will start with the 8086 microprocessor interrupts. So, in the previous lecture, we have studied different types of programmings, logical, arithmetic, and time delay program. So, time delay programming means how much time it is required to execute such a program. So, today we are going to start with the interrupt. So before going to the interrupt, I want to explain you, or I want to keep in your mind that what is exactly meaning of interrupts. Okay, first you know the meaning of interrupt, or the meaning of the word interrupt. Suppose I'm taking very a real time example. Suppose I'm taking a lecture in a classroom, right? So I'm in very good flow. You are understanding whatever I'm telling to you. You are also in very good grip, and suddenly someone come and knock the door, and he called me outside of the class, and I went outside the class and I discussed something with that person. Okay, after 5 minutes I came back into the class, and I'm continued my class till my whole 1 hour. Now this is suddenly someone has come and he called me back out of the classroom. So that is called as an interrupt, right? Some process is ongoing, and somewhere in between there is a some interrupt, or you can say some disturbance. Okay, and after that, after that I'm solving that whatever the issues with that person outside the classroom, and again I came back in the 5 minutes, and wherever I left that lecture, I'm going to start again from the same topic. That is called as a interrupt. Okay, so in the programming also there is also interrupt. Sometimes some programming is running out, okay, and some interrupt is arrived, and that interrupt, it stops your program, okay, and it will go to that interrupt. After recovering that interrupt, again it comes to the main program and your execution will start. Okay, so that's what kind of interrupts and what exactly and why this occurs that we are going to see in this lecture. So I hope you understand what is the meaning of interrupt. So these are the content that we are going to discuss in our lecture. So hardware interrupts, maskable, non-maskable, software interrupts. Okay, so the meaning of interrupt is to break the sequence of operation, right? So whatever the operations are going on sequentially, that are going to interrupt. Okay, so while the microprocessor is executing a program, an interrupt breaks the normal sequence of execution of instructions, diverts its execution to some other program called interrupt service routine, right? Suppose the microprocessor is executing a program, then suddenly a interrupt occurs, and what it interrupt does, it breaks the. So likewise, I perform, when I left my lecture, I perform whatever the issues with that person which is outside the classroom. I solved it, and again I come back. Okay, so I again come to the main program. Okay, so likewise the processor again come to the main program and it will execute. Okay, so it is called as an interrupt service routine. Okay, so after execution, the control returns to the back again to the main program. So whatever the interrupt, it will execute it and again come back to your main program. Okay, that is nothing but the interrupts. So keeping moving until interrupted by the sensor. Okay, so they are sensor interrupted sometime. So interrupt receive, then do predefined operation. So there is some predefined operation that you have to perform when interrupt is received. Some interrupt is occur, then you have to perform the predefined operation. After finishing the interrupt, after finishing the interrupt service, return to the normal operation, keep moving forward again, right? After performing the interrupt operation, it again come to the main program, and it keep moving or keep performing the same execution of the program, and it keep going ahead. Okay, so that is what interrupt. It is not like that. Suppose you are performing the interrupt and it will go on somewhere and it will not come back to your program. Okay, so that is what the process of doing the interrupt service routine. the processor can be interrupted in the following ways. Now, in your mind, there will be the question. Now, this when this interrupt occurs, why there is a need of this interrupt occurs? If the execution of the program is going on, is there is a really need to be a program is interrupted? Some by the peripheral. Okay, some you have connected some peripheral devices. Okay, suppose you are connected the keyboard or sensor, and that sensor is occur some another signal. Okay, by external signals, then interrupt can occur by an internal signal generated by a special instruction in the program. Sometimes there is some instruction interrupted instruction programs are executed. That is time also there is a interrupt can occur by an internal signal generated due to an exceptional condition which occurs while executing an instruction. Okay, sometimes what happen, sometimes such a conditions occurs while during the program, so the programmers cannot decide what to do, so at that time interrupts can occur. So now we will see, this is very important slide. So there are types of the interrupts. So there are main two types of the interrupts. First is a hardware interrupt, another is a software interrupt. Okay, so hardware interrupt is having again two types. It is one is a maskable interrupt and another is non-maskable interrupt. And software interrupt is having one type, that is 256 types of software interrupt. Okay, so we cannot define that there are almost type 0, type 1, type 2, almost 256 types of software interrupts. Okay, so we are going to see those are. So hardware interrupt. So now what is the hardware interrupt? The interrupt initiated by external hardware by sending an appropriate signal to the interrupt pin of processor is called hardware interrupt. Okay, so if you are going to the pin description of the my lecture of pin description, there is one pin, interrupt pin. I hope you are understanding. Whenever I am sending the interrupt signal to that pin, then your processor will be interrupted, and the hardware, that is called as a hardware interrupt. Okay, whenever you are interrupted by the some external signal to that pin of the microprocessor, that is called as a hardware interrupt. And the 8086 processor has two interrupts pin. First is a INTR interrupt and another is a NMI. Okay, that is nothing but non-maskable interrupt. The interrupt initiated by applying appropriate signal to those pins are called hardware interrupt of 8086. Whenever we are applying some signal, some external signal to that those pins, those two pins, that is interrupt and NMI, that is nothing but the hardware interrupt of 8086. I hope you understand. Now, I know there are two types of interrupt, hardware interrupts. First is maskable interrupt and another is non-maskable interrupt. Now you can see pin number pin number 18. Okay, you can see pin number 18, that is nothing but the interrupt pin, that is called as a maskable interrupt. Okay, so if you have generated the maskable interrupt, then the signal is given to the pin number 18, that is interrupt. And another you can see the non-maskable interrupt. Okay, that is NMI pin, that is pin number 17 of the 8086 microprocessor. If you have generated the non-maskable interrupt, then it is connected to the, or the signal is given to the NMI pin number 17. So keep in mind always pin number 17. When this hardware interrupts occurs, okay, there is another question in your mind, when these hardware interrupts occurs during the execution of the program. Okay, so there are some cases, so used to handle the external hardware peripheral such as a keyboard, mouse, hard disk, floppy disk, DVD drivers and printers. Whenever you are using these external hardwares, at that time there is a more chances of occurring the hardware interrupt. So they have shown here. So these are suppose keyboard, you are connected externally to your 8086 microprocessor, sometime mouse, hard disk, floppy disk, DVD driver. Okay, whenever these are connected, then hardware interrupts can occur. Now the processor has the facility for accepting or rejecting the hardware interrupts. Okay, so it is not always whenever you are generated and then he will accept your interrupt. So the processor is having that facility or rights that whatever the interrupt is generated, it can be accepted or rejected. The programming the processor to reject an interrupt is referred to as a masking or a disabling, and programming the processor to accept the interrupt is referred to as an unmaskable or enabling. Okay, suppose there is a programming you have generated or you have written the programming in the processor. Suppose you want to reject the interrupt. If you want to reject the interrupt, then it is referred as a masking or disabling. Okay, masking or disabling. And whenever you have to accept the interrupt to the microprocessor, then it is referred to as a unmaskable or enabling. Okay, so to unmask or enable all hardware interrupts. Okay, what you have to do if you want to enable the hardware interrupts means whenever there is a interrupt generated by the hardware signal, then processor has to accept it. Then what you have to do, you have to set the interrupt flag 1. Okay, set the interrupt flag 1, and if it is clear to 0, okay, if it is clear to 0, to mask or disable a hardware interrupt except NMI. Okay, then you have to set the NMI pin, that is pin number 17, to 0. Okay, what is meaning of this? This is nothing but all the interrupts are disabled, so no interrupt can occurs and it will disturb your program. The interrupt whose request can be either accepted or rejected by the processor are called maskable interrupt. Okay, those are called as a maskable interrupt. So what? So your NMI pin. Okay, so your NMI pin should be what? It can be a 0 or 1 according to your interrupt can accepted or rejected. It depends on the value of NMI pin. Now, the interrupt whose request has to be definitely accepted or cannot be rejected. What am I telling? I hope you are understanding. The interrupt whose request has to be definitely accepted or it cannot be rejected because the processor has to accept that request. So that is called as a non-maskable interrupts, right? So whenever you have generated the interrupt, the processor must has to accept that interrupt, that is called as a non-maskable interrupt. Whenever a request is made by non-maskable interrupt, the processor has definitely accept that request and service that interrupt. Generated or non-maskable interrupts occur, the processor has to accept that request, and whatever the operation is going on or whatever the operation the processor is performing, he has to stop that operation and perform the interrupt. You have to the processor has to perform the interrupt operation, that is called as a interrupt service routine. Okay, so that is very important. What is interrupt service routine? In 8086 processor, all the hardware interrupts initiated through INTR pin are maskable by clearing the interrupt flag. Okay, so interrupt that INTR pin can be performed by using these hardware interrupts, and the interrupts initiated through NMI pin and all software interrupts are non-maskable. Keep in mind, all software interrupts are non-maskable, means they have to accept the processor. The processor cannot reject your interrupts. Okay, so here I am shown one diagram again. So the maskable interrupt and non-maskable interrupt. So what is the non-maskable interrupts? The programmer cannot control when non-maskable interrupts is service. Okay, so programmer cannot be controlled, and the processor has to stop the main program to execute the NMI service routine. Okay, whenever the non-maskable interrupts occur, the processor has to stop their service and he has to perform the execution of the or ISI, that is interrupt service routine. Okay, ISR. And when there is a maskable interrupts, the programmer can choose to mask specify interrupt and renewable them later. So this maskable interrupts, the programmer can be choose that it should be accepted or rejected. So it can be done by using the NMI pin setting 0 or question. So when these non-maskable interrupts can be used, so what kind of these non-maskable interrupts are? Okay, so first when it can be generated when there is a power failure. Okay, it can be used during power failure. Suppose suddenly there will be the power failure, then it can execute the non-maskable interrupt. Then use during the critical response time. Okay, there is a critical response time used during the non-recoverable hardware errors. Suppose there is a hardware error, suppose in a sensor there is a failure in a sensor. Okay, at that time, suppose without a replacement there is no option, then this is a non-recoverable error. So at that time the non-maskable interrupts can occur. Used watchdog interrupts also, and used during the memory parity error. Suppose there is in a error in a memory parity, so at that time also non-maskable interrupts can be used. Now we will move toward the software interrupts. Till now we have just discussed about the hardware interrupts. There are two types, maskable and non-maskable, and which can be and when they can occurs and when they can be used. Now the software interrupts are program instruction, and these instructions are inserted at a desired location in a program. Okay, now what these software interrupts are nothing but what? These are nothing but the instruction of, and they can be inserted while writing the program. So whenever that instruction executed, there will be the interrupts. While running a program, if software interrupts instruction is encountered, then the processor initiate an interrupt. The 8086 processor has 256 types of software 5. Okay, so there are the 8086 processor has 256 types of software interrupt, and the software interrupt instruction is a int, where n is the type of number in the range 0 to 255. So there are almost type 0 to, so there are int n means 0 to 255 total software interrupts are available. As well as used as a communication mechanism between different parts of the program. Whenever you have to do the communication between the parts of the program, is at that time these software interrupts can be used. Now we will see what are the different types of software interrupts. So there are 256 interrupts of 8086, and they are divided into three groups. Now we will see which are these three groups. First is type 0 to type 4 interrupts. Now this group are used for fixed operation and hence are called as a dedicated interrupts. Okay, whenever you have to perform the fixed operation, then this type 0 to type 4 interrupts can be used. So in the further slides we will see what are the different dedicated operations of each type 0 or each type interrupts. Now we will move towards the next group, that is type 5 to type 31 interrupts. They are not used by the 8086, they are reserved for the higher processors like 80286 and 80386. And we will see the group 3. So group 3, that is type 32 to 255 interrupts. These are available for users called user defined interrupts, and these can be a hardware interrupts and activated through INTR line or can be a software interrupts. Okay, so mostly only a group 1 interrupts can be used while doing the programming. Now we will see which are these interrupts. So type 0 did divide the error interrupts, means what? Whenever there is a question is a large, can be fit in L or X or divide by a 0, then type 0 sometimes what happen, whatever the question is generated, it cannot be fit in a register AL or a AX, that is 16 bits. So it is more than 16 bits. At that time what happen, this type 0 error interrupt can occur. Then type 1 single step interrupt, so used for executing the program in a single step mode by setting a trap flag. Okay, whenever you have to generate it or whenever you have to execute the program in a single step, then this trap flag can be, or this interrupt can be occurs. Then type 2, that is a non-maskable interrupt. This interrupt is used for execution of NMI pin. And type 3 breakpoint interrupt, used for providing the breakpoints in the program. Sometimes we have to check the execution of the program and where is there any error, so there is a needed to put the breakpoint in between. So this type 3 can be used for the breakpoint interrupts. And the type 4, that is overflow interrupt, used to handle any overflow error. Suppose there is a stack or queues, suppose they are overflowing, okay, data in the memory, so that time this overflow interrupts can occur. So now we will move towards the conclusion. The CPU executes the program. As soon as a key is pressed, the keyboard generates an interrupt. The CPU will respond to the interrupt and read the data. After that, return to the original program. So by proper use of interrupts, the CPU can serve many devices at the same time, right? So what it can exactly, the CPU will respond to the interrupt, read the data. After return to the original program, again it perform the same. And what exactly the maskable, non-maskable interrupt, hardware interrupts, then software interrupts, and what are the different groups of software interrupts, and what groups and what exactly these interrupts can be used into the program. So thank you very much for today's lecture. I hope you understand the interrupts. If you have any doubts, you can simply message me or call me, or you can simply write your question in a comment. So thank you very much for today's lecture.